then it will throw me the error. So if I just say message blow your phone UIT UTE. So if I try to print ln, damn, okay, rest. So it will throw me an error. Let me see. Yeah, cargo build. Yep, throws me an error. Like, I can do cargo check too. Cargo checks does the same thing. Okay. So rust equals to 53 pass. Type must be known at this point, and type annotation needed. Okay. Consider giving rust an explicit type. So rust, if I say I8, sorry, 8, will it accept? Not sure, but check. Okay, warning. So it does accept. I don't know the limitations of this thing, but yeah. So 32 is the given thing, and I can go to 64 too. So both the things seems to be valid. Okay, now let's see. So if you don't add, okay, annotate, okay. You see different types of annotation for other data. Scalar type. A scalar type represents a single value. Rust has 4 primary scalar types: integers, floating point, numbers, booleans, and characters, which I did not know. You may recognize these from other programming languages. Let's jump into how they work in Rust. Sweet spot, baby. Yeah, sweet spot. Okay, integer types. An integer is a number without a fractional component. We use one integer type in chapter 2, the U32 type. This type indicates that the value is associated with the sound be assigned integer, and assigned integer type starts with I and instead of U. Okay, unsigned means it can go both positive and negative ways. So that's the real difference there. Okay, that takes up 32 bits of space. Table, okay, 3 hyphen 1. I don't know what this symbol is exactly, but that's the case it seems to be. Okay, shows the built-in integer types of Rust. We can use any of these varieties to declare the type of an integer. Nice. So far I can understand everything. Please Rust, be generous with me this time. Each variant can be either signed or unsigned and has an explicit size. Signed and unsigned refers to whether it's possible for a number to be negative. In other words, whether the number needs to have a sign with it. Signed, or whether it will only be positive and can therefore be represented without a sign. Unsigned. Okay. It's like writing numbers on paper. When sign matters, a number is shown with plus sign or a minus sign. However, when it's safe to assume that the number is positive, it's shown with no sign. Okay. Oh, okay. I completely got it wrong. Okay, fuck. Sign numbers are stored using two complement representations. Okay, two's complement representation. Sorry. My reading is not that good. Each sign variant can store numbers from 2 power n minus 1 to 2 power n minus 1 minus 1. Okay, negative minus. Okay. Inclusive. So, not exclusive, inclusive, where n is the number of bits that a variant uses. So, an I8 can store numbers from 2 power 7 to 2 power minus 2 power 7 to plus 2 power 7 minus 1, which is equals to minus 128 to 127. Let's give it a right. Let's give it a test. We are practically learning Rust, so I wanna hit every point that exists. So let n of I8 b equals to minus, okay, unsigned, minus 400. Can I print len? Hey, come on, god damn it. Be fast with me. If cargo check cannot apply operator, okay. If it's signed, can I check? Okay. Wow. Getting string is never used. Okay, that's okay. Literally out of range for it. And Rust compiler messages are so definitive. I mean, I can understand the error without even needing to go to 128. Ideally supposed to work. Yep, works. And even if it's one digit out, not gonna be possible. Check, not gonna work. And 8 is not supposed to work. Yes, 7 should work. Awesome, 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 awesome. So we are in this place right now. Let's just say, additionally, where were we? Okay, unsigned variants can store numbers from 0 to n minus, okay, positive side. So u8 can store numbers from 0 to 2 power 8 minus 1, which is what, 255. Eh? So unsigned can only go up to 255. Okay, this unsigned 8 has more flexibility in some ways. I'm not sure, like, so I8 can only go up to, okay, 2 power 7, and IU8 can go up to 2 power 8. Just because it is unsigned, it has this cargo check, and if I go to 8 now, how do I check the upper limit? I don't know how to check the upper limit, but let's just assume, uh, let's just check why ChatGPT might answer us. So silly of me, but yes. Why I8 in Rust can only go up to 127 and U8 can go up to 255, I guess. Let's see the reason. Okay, let's see. In Rust, I8 and U8 are 8-bit signed and unsigned integer types respectively. The reason why I8 can go only up to 127 and U8 can go up to, unsigned integer 8 can go up to 255 is due to the way these types are represented in binary form using 2's complement representation. Okay, right. Man, the book is always right. I don't know why, but book is so awesome. Rust book is so awesome. It mentions every goddamn thing and we fail to notice it most of the time. Okay. The I type is signed 8-bit integer, which means it can represent both positive and negative integers. The range of values from I8 can represent from minus 128 to plus 127. Here's how the range is calculated. Minimum value Okay, maximum value. Awesome. Okay, type is unsigned 8-bit integer, which means it can only represent a non-negative integer. The range of value that a U8 can represent is from 0 to 255. Okay, here's how the range is calculated. Maximum value 0. Sorry, minimum value 0. Maximum value 2 power 8 minus 1, 255. Okay, 2's complement representation in binary form. 2's complement representation, the most significant bit is used to represent the sign of the numbers. Okay, okay. For I, 0 represents the positive number and 1 represents the negative number. Oh, oh, okay, that's the difference that it has. Because if I just go here and say, like, it will be something like for I8, man, comments. For I8, it will look, god damn it, look like this. It will be 1 or 0 as the starting thing bit, so that the compiler or the memory space knows the number is false or negative. Okay, okay. And in case of U8, the bit which was used to store sign is not used, so that space is also used to store the value of the number. Oh, that's nice, that's nice, that's nice. That's something that can help me in the long run. Okay. Why does this happen? The reason for this difference is in range between I8 and U8 is due to the way signed and unsigned integers are represented in binary form. Okay. I8 is like 2 power 8 minus 1 on the positive, sorry, U8 is 2 power 8 minus 1 on the positive side, and I8 is something like 2 power 7 minus 1 on the positive side and 2 power 7 on the negative side. Because you have to specifically mention the sign on the first bit, and for you don't need to do that. That's awesome, that's awesome. Good progress, brothers. So where were we? Yeah. Okay, where were we? Each variant can be either answered. Okay, signed and unsigned refers to whether it is possible for a number to be negative, or in other words, number needs to be signed. Whether, okay, this is something which I already read, so sorry. So how do you know which type of integer to use? If you're unsure, Rust defaults are generally good place to start. Integer types default to I32. The primary situation in which you use I size or U size is when indexing some sort of collection. Okay. Integer overflow. Let's say you have a variable of type U8 that can hold values between 0 and 255. If you try to change the variable to a value outside the range, such as 256, integer overflow will occur, which can result in one of the two behaviors. When you are compiling in debug mode, Rust includes checks for integer overflow that causes your program to panic at runtime. If this behavior occurs, Rust uses the term panic when program exists with an error. We'll discuss panics in more depth in unrecoverable error with panic section in chapter 9. That's a future video, god damn it. Future video it is. Okay. Okay. How much do we left? We got a hell long way to go. Okay, when you're compiling in the release mode with this release flag, Rust does not include checks for integer overflow, thus causing panics. Instead, if overflow occurs, Rust performs two's complement wrapping. In short, value greater than the maximum value the type can hold. Wrap around to the minimum of the value that type can hold. In case of U8, the value 256 becomes 0. The value of 257 becomes 1, and so on. Thus, program won't panic, but the variable will have the value that probably isn't what you are expecting to have. Relying on the integer overflow wrapping behavior is considered an error. Okay. So if I run this thing in release mode, I will not get compile time, I mean check time one. So if I, how do I cargo run yeah, 257, and if I, like, let me save it first, and I'll go here, uh, really, yes, how, that's, how do I, really, yes, compiling, okay, rust, mm, build, build, uh, rust, and god damn, rust, yeah, rust, oh, sorry, yeah, DOL, it is throwing. Why it is throwing? I'm not sure why the hell it is throwing now. I don't wanna know. But it's not supposed to throw. Like, it's clearly mentioned when you run it in the release. It's not supposed to be like this. And why is it acting like that? Like, how do I run Rust in release mode? How do I compile Rust in release mode? How do I CMPI Rust in release mode? Let's just see. Compile and run Rust program. Okay, enabled. Acha, cargo run. So if I just go and say cargo run release, nope, nope. It was ideally supposed to overflow, and it was supposed to be handled. Why the fuck it is not doing it? Why the fuck it is not doing it? Oh, okay. So what they are saying right now, you people can understand, is that whenever I run this in release mode, it is supposed to ignore this like unsigned 8 overflow, and I cannot see that happening right now, and it's pissing me off. It's bloody pissing me off. Please help me out. I want to check that case. So how do I cargo run release? Okay, I'm writing a program that's quite compute heavy. It's annoying, slow to run in debug mode. My program also plagued by integer overflow. Then you fucking had to correct it, because I'm reading data from U8 array, and U8 type spreads to unexpected places via type interface, and Rust prefers to overflow rather than promote integers to larger types. Yeah, obviously that's written in the manual. You had to handle it yourself. I don't know why you did it in that way, but okay. Man, that's your fault in every way. So when you're building an array and you're specifying that it will not go over 255, you had to be careful, dude. Okay, 8 years, 4 months ago. Okay, I'm sorry. This guy must be one of the initial G's who made this possible. But yeah. So now the question which I'm looking for right now. How do I run Rust in release mode, brothers? Customize build and release profile. What does release profile actually do? I don't want to know. Force compiler to function rather than optimize it. Yeah, how do I force the compiler? Please let me force it. I wanna force the compiler so hard that I lost a word there. It was bloody slutty. Okay. Cargo release mode. Cargo build release. Can I? Cargo. Cargo build. Yes. Nope. Why the fuck does it not work? Please help me, God. Please help me. I'm this one. I'm bloody agitated right now. Yeah, GPT. You know how bloody hell run Rust in release mode. Just for ChatGPT, my typing sucks. Cargo run release. Can I? Let's see. Okay, it still throws the shit. I'm not interested anymore. Okay. Rust does not include the program won't panic, but the variables will have value that probably isn't where you're expecting it to have. Relying on integer overflow wrapping behavior is considered an error. That's the part I read. Man, I should bloody build something which will tell me till where did I read actually, because I end up double reading the same shit again and again. To explicitly handle the possibility of overflow, you can use the families of methods okay, provided by the standard library of primitive numeric types. Awesome. Wrapping in all modes with wrapping underscore star methods such as wrapping underscore add dot. Okay, return none value if there is overflow with checked a method. Return the value and boolean indicating whether there are overflows in the overflow method. Okay, saturated at the value minimum or maximum value within the saturated method. Okay, floating points. Floating point types. We just crossed integers right now. We got hell lot of way to go. Floating point types. Rust also have two types of primitive types of floating point numbers, which are numbers with decimal points. Rust floating point types are F32, F64, which are 32-bit and 64-bit in size, respectively. The default type is F64. Because of modern CPUs, it's roughly the same speed as F32, but it's capable of more precision. All floating point types are signed. Yes, signed. Yeah. Here's an example that shows floating point numbers in action. So I can just say let x equals to 2.0, and or I can specify what floating size should I use. 32-bit variant or 64-bit variant. I have to, like, for 32 I have to manually mention it. For 64 I can. And how do I check? I don't know. Like, let's see. That seems very decent, so I don't want to implement it in any way. Floating point numbers are represented according to IEEE 754 standards. The F32 type is single point precision float, and F64 has double precision. Precision. How do you say precision? Precision. Precision. I I suck. Numeric operations. Rust supports the basic mathematical operations you expect from all the numeric types: addition, subtraction, multiplication, division, and remainder. Integer division truncates towards 0 to the nearest integer. The following code shows how you'd use each numeric operations in a let statement. Okay, awesome. So let sum equals to 5 plus 10. Awesome. Let's difference equals to minus. Let product equals to star. Obvious. And this is something which I'm looking forward to. Quotient equals to, okay, divide. Okay, divide. And this is modulo operator. And this is okay, truncated. I guess that's the way you pronounce it. Yes. Okay. Each expression in these statements use a mathematical operations and evaluate to a single value, which is then bound to a variable. Appendix B contains the list of all operators that Rust provides. Awesome. Don't want to know it right now. Boolean types. As in most other programming languages, a Boolean type in Rust has two possible values, true and false. Booleans are 1 byte in size. Boolean types in Rust is specified using bool. For example, like all the other language, Rust does the same thing. But Rust is freaking awesome for various reasons, so I wouldn't complain. I wouldn't complain in any way. So half an hour into the stream, we are going good. And 0 followers today. I would encourage people to follow. Nah, I'm just watching myself, so The character type. Rust char type is the language's most primitive alphabetic type. Here are some examples of declaring char values. Char values, sorry. Char. Okay. Note that we specify char literals. Okay. I can just say we and my eyed cat. Okay, heart-eyed cat. Oink. Oink. I can do that. Note that we specify character literals with single quotes as opposed to string literals which use double quotes. Rust char types is 4 bytes in size and represents a Unicode scalar value, which means it can represent a lot more than just ASCII. Ascendant, ascent, actent. I don't know. Bloody hell. Where did I go? Okay, Chinese, Japanese, Korean characters, emojis, zero with space, and all variable values interest. Okay. Unicode scalar values ranges from U0000 to UD7FF and UE000. Okay, inclusive. However, a character isn't really a concept in Unicode, so your human intuition for what a character is may not match up with what a character is in Rust. We'll discuss this topic in detail in storing. Okay, UTF-8 encoded string with text with strings in chapter 8. Ideally hope so I will understand that thing by then. Not sure. Hmm. Okay. Okay. Compound types. Compound types can group multiple values in one type. Rust has two primitive compound types, tuple and arrays. Okay, compound types are something which I'm not that familiar with due to my background in C++ and other dumb shit languages like JavaScript, TypeScript, C Sharp, C Sharp, bloody hell, and Java. I'm using Java in my day-to-day job, so please have mercy on me. Awesome. Okay, a tuple type. A, okay, a tuple in general way of grouping together a numeric a number of values with variety of types into one compound type. A tuple have a fixed length. Once declared, they can grow or shrink in size. Sorry, they cannot grow or shrink in size. Interesting. Let's just say let's see. Okay, we create a tuple by writing comma separated list of values inside parentheses. Each position in the tuple has a type, and the type of different values in the tuple doesn't have the same. We add optional types and annotate in the example. Okay. So can I create an array of tuples? I guess I can. So let's just see how a tuple works. Like if I want I32 and F64. Uh, uh, yeah, 32 and F60, F32. I don't want extra precision here, and I can just input values as 1 and mm, and if I try to print it, cargo, how do I print it? How do I print it? Okay, okay, let's let up equals to, okay, okay, let x y z. So how do I declare what type of 0? Not sure, but I'm just giving nup. Okay, cannot index the value of type. To access tuple element, use. Okay, let's see. Wow, I know Rust compile you are good. Not this good. God damn, Rust. So I can just say 1. I get 2 points. Oh, awesome. I love Rust for this reason. One of the reasons I just added it into my book so that I can list the reasons of loving Rust. Loving Rust. Loving. Ole, 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 ole. Okay. Tab bind it to an entire tuple because of tuple tuple. It's tuple or tuple? Not sure. Is considered a single compound element. To get the individual value of a tuple, you can use pattern matching to destruct a tuple value like this. Destructure. Oh, destructure. Destructure. Tuple value like this. I can just store the values which I want to store, and I can just select xyz equals to tup, and I can individually separate the values. That's awesome. Let's give it a shot. So I can just say let n equals to 1 comma 2.1 comma character a, and let x y z equals to yeah, and I can just print what z. I can check. Okay. Oh, sorry, man. I gotta do less typos now. Cargo run. Awesome. Works. And who am I to question Rust compiler? But yeah, I'm taking my shots here. Okay. Uh-huh. Okay, this program first creates a tuple and binds it to the variable tup. Then it uses a pattern with let to take tup and turn it into 3 separate variables. And okay, this is called destructuring because it breaks a single tup into 3 parts. Finally, the program points the value of y, which is 6.4, when we can access a tuple element directly by using a period followed by the index. Yeah, I just figured it out right now, so not interested because I already know it. That's how awesome I am. I can boosting myself. Okay, this program creates the tuple x, then access. Yeah, I saw that. Array types. This the juice array types. Another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. Unlike array in some other languages, array in Rust have fixed length. We write the value in an array as a comma separated list inside a square brackets. Okay, okay, and yeah, similar to other things, but mm, curly brackets and here square brackets. That's the difference. Arrays are useful when you want to collect data and stack rather than the heap. We will discuss the stack and heap more in chapter 4, or when you want to ensure you always have a fixed number of elements. An array isn't as flexible as a vector type, though the vector is similar collection type provided by the standard library that is allowed to grow or shrink in size. If you're unsure whether to use an array or vector, chances you should use a vector. Classic, classic. Okay. Arrays are more useful when you know the number of elements will not change. For example, if you're using name of the months in the program, you would probably use array rather than a vector because you know it will always contain 12 elements. Awesome. That's awesome. That's awesome. That's awesome. Okay, you write an array type using square brackets with type of each element and a semicolon and then the number of elements in the array, like so. So it will be something like let a equals to I32 is the type of array. Okay, and 5 is the number of elements. Let's give it a shot. Let's give it a shot. Let's let everything get a shot. That's what we are planning today. We are bloody planning for everything to get a shot. And let array equals array of I32 and I want 5 or no 3 elements equals to 1 2 3. Okay, for I don't know how for works so far, so let's just say println. I can say array of 0. Man, I'm still trying to get used to this. Okay, expected one of this found. Oh, what the hell? Yo. Oh, okay. Awesome. Okay. Uh, hmm. Okay. Let's go. Let's go. Accessing array elements. I already know that part. Invalid array element access. Yeah, if I go out of the index size, I would probably face the error. Let's see what happens if you try to access an element of an array with past the end of the array. Okay, thread panicked. Len 5 is bound, but index is okay. I understood. Okay, that's the end of this part. I probably should go fill my checklist up. Where are you? Yep. So I guess this part is done. Yep. Yeah, let's see what we are doing next. 43 minutes into the stream and we are done with data types. Let's go see functions. Please make it a short chapter. Might be a shorter read if I do it properly and if I'm familiar with the concept. Functions are relevant in Rust code. You're already seen one of the most important functions in the language, the main function, which is entry point to the point of many programs. You also seen the fn word, which allows you to declare new function. Got it. Rust code uses snake case as the conventional style for functions and variable names, in which all letters are lowercase and separate separate words. Here's a program that contains an example function definition. I got addicted to snake case because of Rust. I wouldn't even argue, but they look nice. For some weird reason, you'll love to use it. Okay, yeah. So we define functions in Rust by entering fn followed by the function name and set the parentheses and curly brackets. Yeah, yeah, we can call a function okay. Yeah, that part I'm sure. Like this is how a normal function in C++ works too. So that's not something which I'm completely unfamiliar with. Yeah, parameters is something which I wanna learn. We can define functions to have parameters which are special variables that are part of function signature. When a function has parameters, you can provide it with correct values of those parameters. Technically, the concurrent values are called arguments. But in casual conversation, people tend to use the word parameters and arguments interchangeably for either variables in a function definition or a concrete value passed into passed in when you call a function. Here's how I came familiar with the word parameters. It's mostly due to people when they are developing APIs, they pass in parameters to the endpoints, and endpoints are nothing but a layer between the main function and the user calling a user URL call. So basically, what we are passing are arguments, but in terms of API architecture, they are called parameters. And somehow this thing got casted onto actual programming input arguments known as parameters. I'm not sure if I can make you understand it anyway, but that's how they became. That's how they might. That's not 100% sure, 100% sure answer, but something struck in my mind when I thought about parameters and arguments used interchangeably. Okay. So, the declaration of another function has one parameter named x, and the type of x is specified in I32 when passed into another function. Okay, okay. So, yeah, I can pass in whatever the hell I want here, and I want to make sure the passing, whatever I pass here, is whatever I want here. And there's this lifetime mentioning in the method. That shit I hate the most. Okay. When defining multiple parameters, separate the parameters with commas. Yeah, that's something which I'm familiar with. I wouldn't read it a bit more. Statement and expressions. Excuse me. Function bodies are made up of series of statements, optional ending, and an expression. So far the functions we covered haven't included an end expression, but you have seen an expression as a part of statement because Rust is an expression based on Rust is an expression based language. This is an important distinction to understand. Other languages don't have the same distinction, so look at what statement and expressions are and how their differences affect the bodies of the function. Statements are instructions that perform some actions and do not return a value. Statements, okay. Expressions are expressions evaluate to a resultant value. Let's look at some example. We actually already used statements and expressions. Creating a variable and assigning a value to it with let keyword is a statement. In Okay, uh, let y equals to 6 is a statement. Okay, okay. Function definitions are also statement. The entire preceding example is a statement itself. Statements do not return values, therefore you can assign a let statement to another variable as following. Code tries to do, you'll get an error. Okay, okay. So function main and let x equals to open bracket, let y equals to 6 close bracket and semicolon. When you run this program, the error you'll get looks like the error says found let statement. Okay, inside another. Okay, that's encapsulate. No, I wouldn't use that word here. That's so wrong. Okay, let y equals to 6 statement does not return a value, so there isn't anything for x to bind to. This differentiates from what happens in other languages such as C or Ruby, where the assignment returns the value of the assignment returns the value of the assignment. Okay, in those languages you can write x equals to y equals to 6 and have both x and y have the value of 6. That is not the case in Rust. Awesome. Rust works differently. Expressions evaluate to a value and make up the most of the rest of the code that you will write in Rust. Consider a math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expressions can be a part of statements in list 3 1. The 6 in the statement let y equals to 6 is an expression that evaluates the value 6. Calling a function is an expression. Calling a macro is an expression. A new scope block created with curly brackets is an expression. For example, yes, let y equals to let x equals to 3 and x plus 1 and print the value of y. This expression can be written also let x equals to 3 and x plus 1. Okay, this expression. Okay, got it. In this block, in this case, evaluate. Okay, function with return values. Function with return values okay, function can return values to the code to the code that calls them. We don't name return values, but we must declare their type after an arrow. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of the function. You can return early from a function by using return keyword and specify the value, but most functions return the last expression implicitly. Here's an example of the function that returns value. Something that I didn't know. Okay, I checked this thing out, it works fine, and you don't need to write return if you're like too sure about what you want to return in the last. But using multiple statements and multiple returns might actually confuse us a bit. Not sure, but okay. There are no function calls, macros, or even let statements in the 5 function, just the number 5 by itself. That's a perfect valid function in Rust. Now, note that function's return type is specified to as arrow mark I32. Try running the code and the output should look like, yeah, okay. The 5 in the 5 is function's return value, which is why the return type is I32. Let's examine this in more detail. There are two important bits. First, the line x equals to 5 shows that we are using a return value of the function to initialize the variable because the function 5 returns 5. Awesome. Okay, that line is the same as following. Okay, second, the 5 function has no parameters and defines the type of return value, but the body of the function is a lonely 5 with no semicolon because it's an expression whose value we want to return. Let's look at another example. Yeah, got the gist of it. Running this code print. Okay, rest of the things are almost similar. I just have to check what. Ah, compile score. Okay, mismatch type. So if I pass in 5, 5 plus 1 is 6. What's the mismatch type? Okay, expected I32 found. Okay, found something. The main error message mismatch type reveals that the code issued with this code. The definition of function plus 1 says that it will return I32, but the statement don't evaluate the value which is expressed by. Okay, got it. So if I don't return I32, instead of that, if I return an expression, it will not accept. Got it. Those are the two agendas which we are in. Comments are similar. Control flow. It's not something which I'm doing today. I want to make it simple. Like we are gonna do control flows in the next stream. Understanding ownership and reference and borrowing and slice types. All four will be like done in the next stream. and I'll be leaving in what, 5 minutes? Not even sure. 5 minutes. I will leave soon, but any questions will be entertained till then. Ah, let me listen to myself.